All right, so this video is meant for those who are going to be virtual or those who just need a little bit more review with graphing and solving by graphing. We started this in a previous class, but now we're coming back to it. So today we will go over once again how to graph a line that is in y equals mx plus b form, and from there we'll learn how to solve a system by graphing. And again, the systems are going to come up in all kinds of situations where we have more than one variable, more than one unknown that we're trying to solve for. And graphing is one technique that can allow us to do that. But of course, in order to solve by graphing, you need to know how to graph a line. So just a quick refresher on this from part one. Okay, we have slope-intercept form. We call it that because m is the slope of the line and b is the y-intercept. And remember that a slope looks, usually like a fraction. 2 over 3 would mean that we want to go up by 2 and right by 3. It really doesn't matter if you go left or right, but it's easiest if you just always go to the right when you're drawing your first point, because then you only have to remember, does it go up or down, right? Negative slope, something like -4/3 would go down by 4. And then again, if you just always go to the right, that's one less thing to think about. Notice, going up and over and connecting is going to give you a positive slope, and going down and over is going to give you a negative slope. All right, and different teachers teach it differently. You probably learned rise over run, or delta y over delta x. But we'll go through a few examples that should hopefully remind you how to do this. Okay, for example, like this, and feel free at any point to pause the video and try these things yourself to see if you're doing them right. Okay, when we're graphing a line in this form, the easiest thing to do is start with your y-intercept, and don't forget to think about the sign in front, whether it is positive or negative. So this is a +1, so we'll put a dot right there. Okay, that's 1 point on the line. Now we need to find at least one more point. And so again, a slope of 2/3 means up 2, and I'm just going to say always go to the right. Always go to the right. So 1, 2, right? You can count the boxes, and then 1, 2, 3, and then make a dot. And then that's good enough. As long as you have 2 points, you're good. Notice if we kept going, this would go off of our graph paper. You can always now go backwards. Just follow the pattern, right? In your mind's eye, kind of trace backwards, and okay, we would end up here, right? So go backwards and left. Okay, and then your line is going to look like that. Remember, they go on forever, so you want to put arrows at the end, and the more of the line that you can draw, the better. Doesn't have to be perfect. Okay, when we're grading these, we're really looking to see that you plotted your dots correctly. It's okay if your line is a little bit crooked, but as straight as it can be is always good. Okay, another example. Here's an example of a negative slope. Again, you might want to pause and try this one yourself. Okay, but we're going to start at +4, put a dot, and then again looking at our slope, but this time it's negative, so we need to just say, okay, instead of going up and right, we are going to go down and right. Okay, so we're going to go down 1, 2, 3, 4, 5, 1, 2. Okay, always go to the right, and you're not going to make mistakes. Always go to the right. You could draw another point, but it's really okay. 2 points is enough for most things. And that's all there is to it. So you're always starting with a y-intercept and then finding another point using your slope. If you had something like this, -2, right, or just a number in front, don't forget that that's really over 1, right? Any number is really itself divided by 1. And so we can say, think about this, 2 over 1. This would mean down and right. Down 2, right 1, and we're going to start at -3, right? We have to include that negative sign. And then down and right. And connect. Okay, it's okay if you don't necessarily go all the way across the graph, but try to draw most of the line. If you're still having trouble with this part, please let one of us know right away. We can continue to help you with this. But if you can't do this, it's going to make the next skill very difficult. Okay, because we're going to start solving by graphing now. But to solve by graphing is really no more difficult than graphing a single line. We're just going to graph two lines. Okay, remember, we are trying to find a ordered pair, right? Some x and y that makes both equations true at the same time. Now, we could do this by substitution elimination, okay, but another way to do it is to graph the two lines and see where they cross, because that is the point that the two lines share. And remember, every point on the line is a solution to the equation. Okay, go one at a time. I'm going to start with this first line here. And we'll start at -3. Almost like the last one we drew, but this time it's a +2. Okay, so we're going to go up 2, right 1. Up 2, right 1. I'm going to draw a bunch of these points, and you'll see why, and I recommend you do this. Draw as many as you can. Even go and, again, follow the pattern, go backwards there. Okay, draw a bunch of points. It'll make it easier. The more you draw, the easier it's going to be to see where they intersect. Okay, now I'm going to draw my other line. Let me switch to a different color. We'll just use blue. Okay, so I'm going to draw this line. Now there's no number here, but remember that really means it's a 1, and that really means it's sort of 1 over 1. So our slope is going to be up 1, right 1. And again, our y-intercept of -1. Okay, and then we're going to go up 1, right 1, up 1, right 1, and hey, we see they're going to intersect. Okay, as soon as you find that point, good enough. Let's just pretend that's straight. Where they cross is your solution. Okay, so don't just draw the picture. We'd also like you now to write the solution or answer, which now is just an ordered pair, right? So you always do the x-coordinate first, so 2, comma, and then your y-coordinate, okay, 1. You can check by plugging the point back in. Okay, so this is your x and y coordinates. So go back to each equation. I'll start with the first one, right? Instead of y, I'm going to write a 1, and then 2. Instead of x, I'll write a 2. And then does that check out? Does 1 equal 4 minus 3? Yeah, we can see that that does. All right, remember, it has to make the other one true also. Okay, so plugging in the second equation, does 1 equal 2 minus 1? Yes, we can see pretty easily. Okay, to solve a system by graphing, again, it's really no different than graphing a single line. We're just graphing two of them, and then just figuring out where they cross. Okay, so we'll go through a few more examples. And again, at any point, you may want to pause and try these yourself. If you don't have graph paper, just draw a rough set of axes, but try to be as neat as you can. I will put graph paper on Canvas that you can print out if you'd like to use that instead. All right, so I'm going to graph the first line. I'll use different colors again. So let's just start with red. Starting at 1, okay, and then a slope of 2 over 1. So up 2, right 1, up 2, right 1. I'm just going to draw a bunch of points. The more I draw, the easier it's going to be to see where they overlap. And then, again, this doesn't need to be perfectly straight, but the better you can, the better the result's going to be. Okay, then we go to our other line. And I'll use blue. There's no number, so remember it's really like a 1, and then that's really over 1. And so starting at 7, let's see, 1, 2, 3, 4, 5, 6, 7, and then going down 1 over 1, down 1 over 1, right? Negative slopes always go down and to the right. And we can see they're going to cross right there. So that means our solution is going to be 2, 5. Right? X coordinate of 2, y coordinate of 5. We can check by plugging that in. Okay, does 5 equal 2 times 2 plus 1? Yeah, we can see that that's going to be 4 plus 1. Does 5 equal negative times 2 plus 7? Yeah, right, that's going to be negative 2 plus 7, so we see that's going to check out. And that's it. Okay, the process is the same every time. The only thing that will change is the lines themselves. For something like this, remember if there is no y-intercept, you can think of that as like adding 0. So you may want to try this one yourself. All right, so I'm going to graph the line now. And I'll just use red and blue again. Starting with this one, again, that's really a slope of 1 over 1. Start at 5 and go up 1 over 1, up 1 over 1. And, you know, just go forwards and backwards a few until you know where they're going to intersect. All right, do the other line now. Let's just use blue again. And again, this when there's no number there, right, you think of that as like, okay, so the y-intercept therefore is just plus 0. And now, you know, down 4, right 1, but if we go that way, right, we're never going to intersect. But remember, the line goes forever, so now go backwards, right? Go follow that pattern in the other direction. Oh, okay, there it's going to intersect. I see now. I've had students tell me, oh, they're not going to intersect. Well, yeah, because they're drawing one line this way and one line this way. And yeah, if you keep going this way, they'll never intersect, but so that means go the other way, right? And they're going to cross somewhere over here. Okay, these lines go on forever. And I'll just complete my other line, and then we will find our solution. Forget the arrows at the end. It's not the end of the world, but try to remember them. All right, so our solution is -1, 4. Oops, sorry. Put that here. There we go. And our check, right? So now we go back to the original equations and we plug in to make sure it's going to work. Okay, does -1 plus 5 equal 4? Yep, that's easy to see. And does 4 equal -4 times -1? Again, yes, that's easy to see. Okay, as soon as you know it's going to work out, you don't have to simplify any further. We're just trying to get you to make sure the answer is in fact going to work. Right, if you get something like 5 equals 1 plus 2, then you know something's wrong, and that means probably one of your lines is incorrect or something like that. Don't just do the check, make sure it actually does make sense. All right, a couple more examples here. Again, why don't you try pausing the video at this point and see if you can get the solution yourself. It should be a nice grid line. All right, I'll start by graphing the first line. I'll just use black ink. Start at 2, down 1 over 2, down 1 over 2, and so on and so forth, and maybe just go backwards a few. Oops. Okay, you can always draw more points if you're not finding the intersection right away. And then come to your other line. It will be different. Let's use purple. Okay, start at -3. And down 3 over 1. Down 3, right 1. Down 3, right 1. Okay, we can see it's not going to work if we go that way, so let's go backwards now. There it is. Now it's going to work. And sure enough, okay, we get our intersection point at 2 and 3, so -2, 3. Okay, one last time doing the check. Plug back into the original equation. -1/2 times -2. Okay, but -1/2 times -2 is just going to be +1. Use a calculator if you need to, with negative signs especially. And then that's going to give me 3 for sure. Okay, same thing in the other one. Plug in 3. -3 times -2 minus 3. Well, that's going to be +6. And yeah, +6 minus 3, that's going to work out. For right now, for things we're doing, it will always intersect on a nice grid line. It's not going to be a situation where like it's in between, because that's difficult to read, and that would mean it's some decimal or some fraction. And while that can certainly happen in real life, we wouldn't solve by graphing if that was going to happen. We would pick a method like substitution or elimination that would give us the exact answer without having to guess. So if this is happening to you, it means you did something wrong. You need to check one of your lines. Usually the slope is the thing that's wrong. Okay, but we're not going to trick you. Okay, that's not going to happen. So maybe try one more example here. Okay, this time with some fractions. All right, let's see how you did. So I'll just keep using purple for the first line, starting at -1, and going up 3, right 4. 1, 2, 3, 1, 2, 3, 4. Okay, 1, 2, 3, 1, 2, 3, 4. And I'll just draw a few points. That's probably pretty good. And connect. Okay, and then come to my other line. And I'll use red, starting at 1 and going up 1 over 4, and they're going to intersect right away. Okay, so again, as soon as you know where it's going to happen, just finish your line. And then get your solution. So in this case, it's going to be 4, 2. Okay, x equals 4, y equals 2. So go back, and yeah, you do have fractions, but you can do this. 2 equals 3/4 times 4. But, you know, you can think of it two ways. What is 3/4 of 4? Well, it's just going to be 3. Or, right, when you divide by 4 and multiply by 4, that's just going to cancel. And so that's going to give me 3 minus 1 equals 2, which we can see. Same thing. 1/4 of 4 is just 1. 1 plus 1 equals 2. And that's the method. And if you can do these examples, then you are all set. And it wouldn't be the worst idea to go back through the video and maybe try these again yourself with a blank piece of paper, if you really want to make sure. One final thing that can happen is sometimes when you graph lines, they don't intersect. And that's going to happen when they are parallel. Parallel meaning they have the same slope. And so if you draw these two lines, right, start at -3 and go up 3 over 1, up 3 over 1, up 3 over 1, and so on. Okay, and then this line here, starting at -5, up 3 over 1, up 3 over 1. They are going to come close. And of course, I didn't draw these perfectly straight. If I had a ruler, I could make these nice and neat. But what you would see is if you connected them, they are never going to touch. They're just going to run right alongside each other like railroad tracks. If they don't cross, then that means there is no point of intersection, and therefore there is no solution. And so that is what you would write for this one. You would say there's no solution. And sometimes we call this an inconsistent system. You may see that vocabulary used sometimes. But I'm happy if you just know when the lines don't cross, when they're parallel, that means there's no solution. That could happen. That could happen on a quiz or a homework assignment, so just be on the lookout for that. And that is the lesson for today. If you have any questions at all, please feel free to reach out to your teacher and ask for help. And there is an assignment on Canvas for me, Mr. Tyler. You know, if you have a different teacher, you might be doing something else, but I'm just going to ask you to do 4 examples solving by graphing. Again, you'll get nice solutions or possibly no solution if they are parallel, and submit that to Canvas when you are done, sometime before the start of our class. If you have graph paper and you want to do it on that, fantastic. If you just want to do it on notebook paper, just be as neat as you can. And of course, you can always do it right on the document itself if you prefer to do that. I will put a file on Canvas with some graph paper if you want to print that out. All right, hope this helped. If you have any questions, let me know. Have a great day.